so yes, I was saying that this line is a straight line. It has a gradient of 3. No matter where on this line, the gradient, the steepness is the same. So if I draw in another graph of y equals to 3x minus 4, in green color it is a different graph, but the steepness is the same. They are parallel. They are just as steep as each other because they have the same gradient of 3. See, all their gradients are 3. Okay? Then I have negative gradients. Y equals to negative 2x, for example. So now, orange line, sloping downwards because the coefficient of x is negative 2. So similarly, I can have y equals to negative 2x plus 5. So I have another line in purple color, which is parallel. They are just as steep as each other at every single point because they have the same gradient. Okay? Then, what about gradients for curves? So if I have a graph that looks like this, y equals to 3x squared, y equals to 3x squared plus 2. Okay, so this curve over here, let's change this 0.4. Okay, now I have a curve that looks like this. What is the gradient of this curve? If I will ask you this question, what's the gradient of this curve? Is it positive or negative? Or is it really a question that can be answered? What is the gradient of this curve? So what does gradient tell you actually? Steepness, right? And we can visualize, we can understand steepness by considering a mountain, by considering a slope. Is the slope difficult to climb? Is it easy to climb? Is the hill easy to climb? So on and so forth. So right now in our classroom, we are standing on a level ground, flat. Gradient is 0. If I ask you to climb a slope upwards, then it is a positive gradient. I ask you to go down the slope, it is a negative gradient. What about this graph? Is it easy to climb this graph? I mean, not really valid, right? Unless I tell you at which point of the graph I am referring to. So for example, over at this point, when x is equals to negative 2, is the graph steep? Is it going downwards or upwards? Okay, let's start with a simpler question first. At x equals to 2, is the graph going downwards or upwards? Down or up? We always consider towards the right, okay? So as we move to the right, when x is equals to 2, is it going down or up? Down, it is going down. So we expect the gradient to be positive or negative. Same concept as your straight line. Going down, negative. So the gradient over here is negative. Over here is still negative, it's still going down. Negative, 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 negative. And now at this point, is it going down or up? At this point, it is flat. Okay? The minimum point over here, it is flat. So what do you think the gradient is? What do you think is the gradient when it is flat? Like our classroom, it is flat. What is the gradient? 0. Okay, gradient over here is 0. Then as we continue to move, are we going up or down? We are going up, right? So we expect the gradient to be positive or negative? Positive, okay. Now, is it steeper over here or is it steeper over here? Which one is more difficult to climb? Over here, when x equals to 1, or over here when x equals to 4? X equals to 4 is more difficult to climb, right? So what can you tell me about the gradient at x equals to 4 compared to x equals to 2? Which one has a bigger gradient? X equals to 4 over here will have a bigger gradient because it is more difficult to climb. Just like our straight lines, we can also have, we can compare y equals to 3x plus 1. Let us compare with something with a smaller gradient, y equals to 2x plus 3 plus 2, for example. Okay, very unfortunate, same color, so the one. Y equals to 2x plus 2. Okay, now I have two graphs of two different colors. The red graph has a larger gradient. This 3 over here is larger than the 2 over here. Larger gradient means it is more steep. Okay, it is more difficult to climb the red graph than the blue graph. So similarly, in our curve, it is more difficult to climb this part of the graph as compared to this part. So we expect the gradient over here to be greater than the gradient over here. And this part over here is flat. So we are expecting gradient equals to 0. Over here, we are expecting negative gradient. So now we have an idea of the sign, whether it should be a positive or negative or 0 gradient. We know how the size of the gradient compares. But how do we assign a value of the gradient? That is where we need to draw something called a tangent line. Look at your textbook, page 142. Textbook page 142, you have a curve in the top of the page. Blue color curve. Weird shape that we don't understand, that we don't know what is the equation. And you see many straight lines that are drawn. Those are your tangent lines. Okay? Yes? Any questions so far? Then I'll show you on Desmos what a tangent line looks like. You can ignore all these things, okay? Ignore everything here. Just know that this is a curve and my red line is my tangent line. You see how it is changing? Okay, let me change the equation. Okay, so now let me zoom out. As my value of x changes, you see the tangent line, it changes as well. Okay, if I were to use a ruler and I place it on the graph, I only want it to touch one point of the graph. As I move my ruler, the tangent line changes. Basically, what I want is to draw a straight line that touches the curve only at one point. Okay? So, in this graph, this circle over here refers to the point on the graph that I am trying to find the gradient. So if I do not have this, I ask you, okay, find the gradient of this curve at x equals to negative 10. Then what you need to do is to take a ruler, put it here, draw a straight line that touches the curve only at this point. Everybody knows how to draw a straight line, right? Everybody knows how to identify where x is. So draw the straight line, it will look like this. It is a tangent line. Then you may, as you practice, you may realize that, how come I can seem to draw a few different tangent lines for the same point? Because they all look correct to me. But don't worry about it. There is a range of answers that we will accept. Because nobody can draw very accurate tangent lines. Even though you may have the correct graph, your tangent line may be slightly different from my tangent line. It may be slightly different from your friend's tangent line. But don't worry about it. As long as it looks okay to me, we will accept it. We will accept your answer. So, let's say I want you to find the gradient at x equals to 10. Find the gradient at x equals to 10. So we find where is x equals to 10. Oh, it's here. And this is the point of the graph. X is equals to 10. I take my ruler, I draw a straight line, and it will look like this. Okay. It will look like this. One straight line that touches only at this point. This is my tangent line in red. Okay? Any questions so far on how to draw tangent line? Noah? Yes, just use a ruler. Draw a straight line on the graph, on the point that we are interested in. So when I ask you, find the gradient of this curve, that is an illogical question. Because different points on the curve has different gradient. I must complete my question by saying, find the gradient of the curve at x equals to something. Because different points have different curves, as shown by this red line that is moving around from different points of the curve. Okay? Different points on the curve has different gradient. But what about a straight line? Like this straight line. Every point on the straight line has the same gradient. Okay? Because it is a straight line. Whereas for a curve, every point has a different gradient. And we can consider very strange curves. Okay, so let me just show you another curve. Okay, weird curve over here. But again, we can find the tangent line. Can you see how it is moving? As I change the x value, the tangent changes. Now it becomes positive, then it becomes 0 over here. Oh, flat, right? Then it becomes negative again, then it becomes 0 again. I can't find the spot, but it becomes 0, it becomes flat, then it becomes positive, 0, negative, 0, positive, 0, negative. Can visualize what a tangent line looks like? Okay, so we were talking about gradient. Why do I keep talking about tangent line? Because we all know the formula for gradient of a straight line. What is that? What is the formula for gradient of a straight line? y2 minus y1 over x2 minus x1. Once I have my tangent line, I can find the gradient of this red line. And that gradient will be the gradient at this point. Okay? One more time. If I ask you to find the gradient of this curve at x equals to negative 10, for example, then you will draw a straight line down that touches the curve only at this point. In other words, the tangent line at x equals to negative 10, then we will find the gradient of this line. The curve is not important to me anymore. Once I have my tangent line, I just find the gradient of this line. And to find the gradient of this line, you just select any two convenient points for you. Maybe this point, negative 5, 0, and maybe this point, negative 15.1 and 60.6. Let one of them be x1, y1, the other be x2, y2. Find the gradient. Rise over run. Okay? Any questions? Alright, then generally that's all for this topic. Okay? No more already. I mean theory wise. Okay? So some examples of tangent lines that are wrong. Okay? So for example, if I ask you to find the gradient at point E, then you need to draw a tangent line, right? So take a ruler. Over here, try to find a straight line that touches the curve only at that point. Draw one line. This is my tangent line at E. It touches only. This yellow line that was given in your textbook, L4, is an example of a wrong tangent line because it is cutting. It is cutting the curve. It is not a tangent. So this is wrong. Likewise, this is also wrong. Okay? Now let us just do a quick practice. I want you to look at the curve at the bottom. Let us try to draw the tangent line at this point. Okay, mark out a cross, and I want you to try and use a ruler to draw a tangent line at this point. try to draw a tangent line at this point. So you need a ruler and a pencil. Done? Okay, so see whether you have the same thing as me. I'll try to position it such that it only touches the curve at that point. So I'm not going to do it this way because it is obviously going to cut the curve. And this looks wrong also. No, you have to follow the curve. Okay, so it should look something like that. This is my tangent line. Okay, let's just randomly try another point. Perhaps let us try this point. Let's try to draw the tangent line on this point. Just choose a point near this region, mark out a cross, and draw your tangent line. Okay, so do you have this? Okay, see, I made a choice. I put my ruler over here, then this is definitely not a tangent line because it is cutting the curve all over the place. So I adjust and I adjust until it looks, okay, this looks possible. This looks possible as well. I think it looks more like this. Okay? So this is my tangent line. It has to touch the curve at the cross. Must touch, cannot have gap. So once you have the tangent line, and if you know the coordinates, if you can read off the coordinates, then you can find the gradient. Maybe this point over here, and this point over here. Find the coordinates, then x1, y1, x2, y2. Therefore, the gradient at this point is equals to the gradient of this straight line, which is y2 minus y1 over x2 minus x1, or the other way around, up to you. Can? Any questions? Anyone okay? Which part don't understand? Basically, right, you need to practice. You can use your ruler and follow, okay? Now we are going to move from left to right. This ruler is going to touch the curve only at one point. So as I move to the right, I have to adjust my ruler such that it only touches the curve at one point. Okay, so what I'm doing is to show you all the tangent lines for different points of the curve. So on and so forth. Okay, which is the same as what I showed you in Desmos just now. Imagine you are riding a roller coaster. This part, you're going up, 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 up until here, you are flat. Then you start to go down very quickly. And we can visualize that with a tangent line going down this way. Then down here, at the minimum point, we are flat again. Then we climb up again, the roller coaster. Okay? Go and practice on what the tangent line will look like. So on page 144 at the top, this formula is very familiar to you. It is your rise over run. Okay? Then let's look at some work examples. Example number 11. Draw the graph of y equals to 4 minus x squared, and they gave you the range. X is from negative 3 to 3. Negative 3 to 3. Anything else, not interested. Draw your table of values. You don't need to show the working, but you need to calculate it properly. Give up to 2 decimal places. Then, once you have the corresponding values, mark them out with crosses. join it with a smooth curve. Label your graph. Must label. Okay, you do not need to show all these things. All the A, B, C, no need. Just the crosses are good enough. Then, now, they ask us to find the gradient of the graph where x is equals to -2. Where is x equals to -2? -2 is here, right? So this is my x equals to -2. I want the gradient of the curve at this line, at this point. So I need to draw a tangent line. So they've drawn it for you already. One tangent line looking like this, green color line. Then find the gradient of the green line. So choose a set of coordinates, for example over here. Because to find the gradient of a line, you need two sets of coordinates. One set over here, you call it -1 and 4, -1 and 4. So you need another point, right? I can choose this point, for example. This coordinate will be -3, -4. So two coordinates, I will now find the gradient. Is equals to 4 minus -4 divided by -1 minus -3. What this is x2, y2, x1, y1. In case you have forgotten. So y2 minus y1 over x2 minus x1. Answer will be 8 over 2, which is 4. Okay? So the gradient of the curve at this point is 4. And in your next page, they also had the same answer, 4. Then the next point that they are interested in is when x is equals to 0. When x is equals to 0, what is the gradient? So again, we find the point where x is equals to 0 on the curve, it is over here. And we draw a tangent. In this case, because it is the maximum point, the gradient is 0. It's flat. Do we need to calculate? No need to calculate already, because gradient is going to be 0. Straight away. Nothing to calculate. But if you want to calculate, it's fine, up to you. So we have one point over here, coordinates 2, -4, and another point maybe over here, 1, 4. Two sets of coordinates, gradient is equals to 4 minus 4 over 2 minus 1. 0 over 1, which is 0. So this is why the gradient of a flat horizontal line is 0. Okay? And the final point we have is when x is equals to 1. X equals to 1 over here. Find the point on the curve. Draw a tangent line. Draw it. Find the coordinates. They chose this as the coordinate and the x-intercept as another coordinate. Rise over run, get the answer. Okay? Now, let us consider example 12. This is a type of application question. A manufacturer wants to make a closed cylindrical can. Closed means the top there is no hole, bottom also no hole. Capacity will be 400 cubic centimeters. And the base of the can is x, the height is h. Express h in terms of x. We know that the volume is equals to 400 cubic centimeters. What is the formula for the volume of this cylindrical can. It will be the cross-sectional area times the perpendicular height. So what is the volume equals to? What is the base area, the shaded part? Yep, pi. But do I have R? Should I use R? X. Because X is the radius, they told you. So pi x squared. This is the area for the shaded part. What must I multiply this by? Multiply by what? To get the volume. H. This is your Sec 1 work. Volume of a prism. Base area times the perpendicular height. And this is equals to 400. Right? Then now they want you to express H in terms of X. That means make H the subject. So now I have pi x squared H is equals to 400. I want to make H the subject. So what do I want to get rid of? I want to get rid of pi x squared. How do I do that? I divide both sides by pi x squared. Divide by pi x squared. So now I'm left with H on this side equals to 400 over pi x squared. Now I have expressed H in terms of X. Okay, so that is given over here. 400 over pi x squared. Alright, so far no graph involved. Then now they say, part 2, let S be the total surface area of the can. Surface area will be given by this shaded part plus this shaded part plus the curved surface area. We know the shaded region is just pi x squared. We need to multiply by 2. But then how do we find the area of this curved surface? Area of curved surface is equals to the circumference times the perpendicular height. Imagine it is. Anybody has a rubber band? Oh, okay, never mind. Okay, so I have a rubber band over here. Imagine this is a circle. Very ugly circle, but imagine it's a circle. And if you know the circumference of this circle, we multiply it by the height. Move it up. Isn't the shape a cylinder? Imagine with me. We know the base, which is a circle. We know the circumference. We multiply the circumference by the height, meaning we move the circle up. We will get a cylinder, right? And by multiplying the circumference with the perpendicular height, we are actually finding the curved surface area of the cylinder. This works for your prisms of other shapes, which I shall not go into. So this will be 2 pi times x, which is your circumference, times h. So since this is the curved surface area, I add that to this shaded part and this shaded part to get a total surface area. So total area equals to 2 pi xh plus pi x squared plus pi x squared. Okay, this gives me 2 pi x squared plus 2 pi xh. Okay, now we compare. Is this the same as this? Are they the same? Almost the same, right? Total surface area, 2 pi x squared. Okay, 2 pi x squared. This is correct already. It's also correct. Okay, plus 2 pi xh. What is this? 800 over x. Does this mean I'm wrong? what happened to the h over here? Is it found here? No, right? No h. H disappeared already. Then you must make use of your answer in the previous part. What did you do earlier on? H, express h in terms of x, correct? So h is equals to this whole thing. Since the h here disappeared, they must have replaced the h with 400 over pi x squared. Okay, so this, I'm going to substitute this inside here. So first term no change, 2 pi x squared plus 2 pi x. So instead of writing h, instead of writing this, I'll write 400 over pi x squared. This was h. And in part 1, we saw that h is equals to this. Same thing. Then now we simplify the easy part. Pi divided by pi is 1. Cancel them. X, cancel, x squared, I'm left with x. Okay? X divided by x squared is just 1 over x. Then this 2 and 400 can cancel now. 2 and 400 can cancel? Cannot. We are multiplying them. 2 times 400. This is 2 pi x squared plus 800 over x. Anybody lost? Anybody lost? Hello, Irfan, do you manage to follow everything? Sure. You mean this part? Okay, let me simplify this. Let me simplify this. So this is pi x squared and this is 2 pi x, isn't it? So far we had this 2 pi x times 400 over pi x squared. This can be changed into a fraction as well by putting a 1 over, over 1. 2 pi x over 1. So 2 pi x over 1 multiplied by this. Yes? Yes? Okay, then now I cancel pi and pi. This one, okay? Okay, then x divided by x squared, right? What is x divided by x squared? X over x squared equals to 1 over x. Okay, so cancel, and the 2 I just cancel lah. Then left with x. Okay, so far? Then I'm left with 2 times 400. So this will be 800 over x. Is this now the same as the question? Yes, I have shown it. S is equals to 2 pi x squared plus 800 over x. So I put it down at the end, showed. Because they ask you to show. So I write down showed. Okay? This is exactly what was done at the bottom part, in part 2. Then on part B, draw the graph for x between 2 and 8. So get all your values in a table form. No need to elaborate, but is it x and y? Do we have an x and y? No, we have x and s. Instead of y, it is now s. So we are going to expect an s-axis, not y, s-axis versus x-axis. Then I just plot, draw the curve, smooth curve. Okay. This thing over here, it just tells you that there are more numbers over here, and they try to shrink it. They compress the s-axis. Otherwise, can you imagine if they draw from 50, 100, 150, 200, then there's going to be a lot of gap over here, right? One big space over here that is empty. So they did this. In your exam, when we set a question, we will avoid these kind of things. So you shouldn't have a need to draw this. Yes, Francis? Okay, you shouldn't have a need to draw this. This is just an example in your textbook that we are going to use to see how the tangent comes in. Now, we have the graph already. They say, use your graph to estimate the values of x for which the total surface area is 350. Total surface area is 350. Do I have a 350 over here? Don't have 350. So we will read from our graph. When x is equals to 350, when surface area is 350, that means this horizontal line, then we see that, at this point over here, 1 point, 2 points. I have 2 points where the surface area is 350, and the corresponding value of x will be 2.6 and 5.8. So how I present my answer will be C part 1. I write down C part 1 to tell the examiner, the marker, that this is the value for x when the surface area is 350. Okay? Then part 2, find the gradient of the curve at x equals to 5. So I find x equals to 5 is here. Go up to the point of the graph. This is the point. And I draw my tangent line. So I draw the green line. And now I want to find the gradient of the green line. Find 2 convenient points. Do your rise over run. So this tangent line has a question number. This is C part 2. And because I am drawing a tangent line and I'm finding the gradient, I want to see 2 sets of coordinates on your graph. Okay? Any questions so far? Then finally, part 3, find the dimensions. Dimension meaning the length, radius, so on and so forth, whatever it is. Where there is the least possible total surface area. So you see, as your x changes, as your radius changes, the total surface area changes as well. When your x increases, your total surface area decreases, then after that it increases. So the question asks for the least possible surface area. Where is the least surface area? What is the smallest surface area according to the graph? Must be the minimum point. This point over here gives me the smallest surface area. See, surface area, it keeps going up, right? The smallest surface area is over here, 300. 300 is the smallest surface area. And what is the corresponding value of x? It will be 4. Okay? When x is equals to 4, I get my smallest surface area of 300. So this is 4, 300. In fact, it should be 300.5 because we have already calculated it earlier on. When x is equal to 4, s is 300.5. So the more accurate value will be 4, 300.5. This is my minimum point. And this is for part C, part 3. So label it as well. So now I know when radius is equals to 4, I have the smallest total surface area. So this is my radius. And when radius is equals to 4, what is the height? equals to 400 over pi x squared. 400 over pi x squared. That's 8. Okay, 400 over pi x squared, you get the height to be 8. So the dimensions, the base should be 4 and the height will be 8 cm. What does this all mean? When you go to a supermarket to buy a canned drink, you see, maybe you want to buy Coca-Cola, and then you see different sizes of Coca-Cola. And you buy based on the volume, right? Based on the amount that you want to drink, not based on the surface area of the can. You buy based on the volume of the Coke. And if I am the manufacturer, I am producing Coke, I want to sell 300 milliliters of Coke. My can have many different shapes and sizes, but the volume is still 300 milliliters. Okay, fixed volume, but the can be very tall with a small radius, or it can be very short with a big radius. Both can also be 300 milliliters. But I want to save money in manufacturing. I want to use as little metal as possible. I want the surface area to be as small as possible so that I don't waste money, right? I don't want to use a lot of metal to give you one canned drink. I want to use as little material as possible. So I want the smallest surface area, but volume is still 300. So that is what is happening over here. This question, the volume is fixed, but the surface area changes as your radius changes. Since you want to have the least amount of material, but keeping the volume constant, then he will draw a graph like this to see how the surface area changes as your radius changes. And we see that the smallest surface area happens when the radius is equals to 4. So this is an application of mathematics in real life that manufacturers can be considering. Okay? Then homework question on 9.4, we'll do some basic ones first. We'll try every question in question 1. Basically, just draw your tangent line and find the gradient. Shouldn't take you more than 1 minute for each question. So 4 minutes for question 1. For this question, you just write down this working on your foolscap paper. I don't expect you to draw this graph for question 1. Okay, so you draw your tangent line on your textbook. So I'll show you another example. This one over here. Draw the tangent line. Then choose 2 points. Find the coordinates. Write it down on your foolscap. Okay, very fast one. See? I'm going to finish drawing all my tangent lines already. Very easy. So 1A, B, C, D. Next will be question 4. Draw one graph. Draw one graph with the correct scale, then draw the tangent line. And let me just choose one last question. Question 6. Okay, that's all for your weekend homework. So the whole of question 1, A, B, C, D, question 4, and question 6 by Monday. No, by Tuesday. Monday no lesson. I mean no maths lesson, right? Yeah, by Tuesday. Okay, and those who owe me homework, submit your or corrections as well. Okay, put it here. 1, 4, and 6. Okay, all those red, orange, submit them. Huh? Yeah, return you. Okay, you pass me that? 9.1. Okay, let me check. Okay, class 10. Darren, please stand. Thank you, class. Have a nice day. Huh? Reject. I returned it to you already. Have I returned it to you? Oh, okay. Yeah, never. Where got reject? 9.1, where got reject you? Never reject you. Okay, then I'll check if it's with Miss Baizua. Okay, go for your next lesson. Oh yeah, before you go on, next week there's a test. Week 9. On grass. Next week. You rejected it to do lah. Only the parts that I asked you to do. Class 10. Good morning, class.